In this lecture, we will see the layout of a CMOS inverter by using the toolbar in Magic. So at first, open the terminal window by pressing Ctrl Alt and T. Type Magic. Press Enter. Wait for the two windows to open. This is the layout window and this is the TKCon window. So type, instead of typing, we'll use the toolbars. So go to options and click on toolbar. Now in order to grid in, press G. Since you can see these are the small squares and these are not visible, so press G. Now in order to zoom in, press Z. Now in order to draw the layout of an inverter, we need one PMOS and one NMOS. So in order to draw the PMOS, we have to select the N well first. So this is the area for N well. Then go to N well and then middle click on it. Now in order to draw the P diffusion layer, select the area and then middle click on the P diff or the P diffusion layer. P diffusion. So now this is the PMOS. We know that the PMOS and NMOS, they must be of equal area. So just zoom out. Now middle click on N diffusion layer. Now the PMOS and NMOS is ready. So first draw the gate. It should be of 2 lambda width. Then middle click on Polysilicon. Okay, so this is the gate of PMOS and NMOS that is being shorted. Now we know that the PMOS is, the source of the PMOS is connected to VDD. So we have taken this as 4 lambda. We can place it over here also. Okay, this is fine. 3 distance from here, 3 distance from here. Then middle click on M or metal 1 and then extend it in this way, in this manner, in 4 lambda form, and middle click on M1. So this is VDD and the source of the NMOS is connected to ground. You can see over here. We can do one thing, we just can extend this layer to one more. Yeah, this is fine now. So similarly over here, select the area and then middle click on and diffusion, extend the poly. Here it's not required. Okay. Now the same area, select place it over here, then middle click on metal 1, then select the area from here to here, and then place it over here. Then middle click on M1. Okay, I have to undo this. Middle click on metal 1. Okay, now the source of NMOS connected to ground, source of PMOS connected to VDD. Now the drains of the two MOS are shorted to each other. Then middle click on M1. Okay, now this is the rough layout. I have to place the contacts. Just expand it. So select the area. This is 4 cross 4. Then middle click on the contact, that is the PD contact. Similarly over here, PD contact. Since this is the P diffusion layer and this is the metal layer, so when they are overlapped, they are disconnected. So in order to make a connection, we have to place the contacts. So you can see over here, select the area and then middle click on ND contact. Similarly over here. Then we have to place some more contacts in the VDD and ground layers, and those are the substrate contacts. So select the area, this is also 4 cross 4, and then middle click on the N substrate contact. Since we have the P diffusion layer and the P well, so we need the N substrate contact over here. Then place another contact over here. Similarly, we can place another with an interval of 4 over here. Similarly, we need a P substrate contact. Here also P substrate contact. And a P substrate contact. So now after placing the contacts, we have to label it. So this is the VDD. So select a square, then right click on the left bottom so as to get this point, and on the tick icon window type label VDD. Similarly in the ground layer, select a square, then right click and type label GND. Next is the input and output. So select the area, then middle click for poly. Similarly, select the area and middle click for metal 1. Select the area, right click, type label VIN, and here type label Vout. Now this is the layout of a CMOS inverter. This is the layout of a CMOS inverter. This is the PMOS, this is the NMOS, this is VDD, this is ground. This is the gate where the input is given, V in. This is the drain, that's where the output is obtained, that is V out. Now after drawing the layout, you have to save the layout. So type save. Let's give the name as inverter or INV, suppose 8. Now if you want to see the DRC errors, whether there are some DRC errors, then type DRC find. So it's written there are no errors. There are no errors in inverter 8, INV 8. Then extract, type EXT. So you can see extracting INV into INV.ext. Then type EXT to sim in order to extract it to sim file. Then if you want, you can extract to spice, but the spice file is not needed for now. Now in order to simulate or execute the layout and see what is the output, you need the sim file. So we have extracted it to sim. Now type Itsm. We will simulate in Itsm. So type Itsm inv8.sim. Then type watch, W for watch, V in and V out, since these are the input and output. Then type D for display. Then give low input to V in and press enter. Press S for step. So when input is 0, output is 1. Give high value to V in. Press S. So when input is 1, output is 0. Now in order to see this in an analyzer, type ANA, V in and V out. If you want to zoom, then zoom to full. So you can see here, this is input V in, this is the output V out. When input is 0, output is 1. When input is 1, output is 0. Now type exit. If you want to see the spice file, type vi inv8.spice. So this is the technology CMOS. The scale is 1U. M stands for MOSFET. This is PFET, that is P MOSFET, and N MOSFET. W by L ratio is same. AD stands for area of diffusion. PD is the perimeter of diffusion. AS is the area of substrate. PS is the perimeter of substrate. So you can see this is same for both PMOS and NMOS, since we have given the same area. Now in order to exit, type :WQ. If you want to see the layout, then type magic inv8.mag, then press enter. So wait for the layout window to open. So this is the layout. Now in order to zoom in, press Z. So this is the final layout of a CMOS inverter. Now let's see how to draw the layout of a CMOS inverter by using the toolbars. First, open the terminal window by pressing Ctrl Alt and T. Then type magic. Press enter. Now this is the TK con window. type grid. Okay, before that, if I don't want to type grid, then I'll type G. If I type G, then this will grid in. If I type G, this will grid out. So now zoom in, go to options, then toolbar. So these are the toolbars. Now in order to design a CMOS inverter, we need one PMOS and one NMOS. The PMOS is drawn over here. So let's zoom out. So select the area, then go to Envel and middle click on Envel. Now this is the Envel. In order to draw the PMOS, we have to select the P diffusion. This is the P diffusion. Now we have to create the NMOS. So select the area and then middle click on N diffusion. Okay. Now for the convenience, let me tell you, this is the whole PMOS, right? So here to here will act as my source. This will act as my drain, and the middle will act as my gate. Source, gate and drain. So the source will be a metal layer. The drain will be connected by metal, but the gates are connected by using the polysilicon layer. So first we will place the gate. So place the gate. Now middle click on polysilicon. So you can see this is my PMOS. Now this is my NMOS. So we know that the source of the PMOS is connected to VDD. So select the, first we will create the VDD layer. So this is the VDD layer. Middle click on the metal one. Okay, now similarly the source of the NMOS is connected to ground. So middle click on metal one. Now the VDD and ground. Okay, we have to connect from here to here. Now middle click. Similarly, connect this to ground. Okay. So the source is connected to VDD. The source of the NMOS is connected to ground. Now let me label. Zoom in. This is the VDD layer. So left click, then right click, left click, right click, then right click on this point on the left bottom. Then I'll obtain this point. In order to obtain this point, we need the left click and right click. Now label VDD and this is label ground. It is showing moving label ground from space to metal 1 in cell unnamed because I have not named it yet. Now VDD and ground are connected. So next we have to connect. This is source, this is gate, drain. Source connected to VDD, source connected to ground. Both the gates are connected. So the drains are also connected in a CMOS inverter. So left click, then right click, then middle click on metal 1. Okay, so now the drains are also connected. Now we have to place the contacts. Now before placing the contacts, okay, first we'll place the contacts. So left click, then right click. It's a 4x4. It's a 4x4 area. Now this is a P diffusion layer. So a metal layer is connected with the P diffusion layer. So we need a P diffusion contact. P diffusion contact. Similarly, over here we need a P diffusion contact. After placing the P diffusion contacts, we need the N diffusion contact. Since this is the N diffusion layer and similarly this metal is connected, if you don't connect a contact, then this will just remain overlap, but this will not be connected. So just for your connection, we need these contacts. Middle click. In order to select, we use the middle click button. Middle click in the mouse. Now this is the ND contact. Similarly, we have to place the substrate contacts in the metal layer. Since this is the N well, so here we have to place the N substrate contact. This is the N substrate contact. Similarly, over here. If we want, we can omit this extra portion by typing erase. We can omit this portion also by typing erase. We need contacts over here also. Now middle click on the P substrate contact. Similarly, over here, we have to middle click. Now for symmetry, you can see there were 3 boxes. So we'll remove this extra box. raise. So you can see if I zoom out, you can see the symmetry of the circuit. It's perfectly symmetrical. The P diffusion layer and diffusion layer are of same area. Then the metals are all of the same area. The contacts are of same area. So now this is the layout. Now we have to mention the VDD and ground are already labeled. Now we have to label the inputs and outputs. So middle click on the polysilicon. We are just extending this in order to name it. Now middle click on middle. Okay. Now left click, right click, type label in. Similarly, label out. Label in and label out. Let's clear this whole portion. Type save. This is the inverter. So INV2. If I write DRC find, there are no DRC errors. Now extract all, extract to spice. Now let's exit. If I type VI inv2.spice, and I'll open this. So you can see there were only one pivot and there was only one pivot and one end bed. The width was 6, the length was 2. The width was 6, the length was 2. As I told you, they were symmetrical. So you can see from the W/L ratio. Now this is the out terminal, out, in, and VDD. This is the pivot. In the pivot, one was connected to VDD. This was the source, this was the drain, and this was the gate. So source was connected to VDD, drain was connected to out, and the gate was connected to in. Similarly, in the NFET, this is the source, drain and gate, same. So the source was connected to ground, the drain was connected to out, and the gate acted as the input. If you want to check it, then open the layout magic inv2.mag. Okay, you can see this is the source, drain and gate. This is connected to VDD, out, in, ground, out, in. Okay, type exit. Before typing exit, this is the whole layout of a 2 input for a inverter, CMOS inverter, by using the toolbar. So exit. Now let's see how to execute the layout of a inverter using Itsm. So open the terminal window by pressing Ctrl Alt and T. Open the layout file by typing magic inv3.mag. This was the layout that we had drawn and the name was inv.mag. Press enter. Exit. It was inv2, which was drawn from the Twisted Schematic. Just zoom in and see. So you can see there are some modifications here, as this is VDD instead of VDD exclamation, and the inputs are given in the form of Vin and Vout, and ground is written as G and D. Now in order to extract, type ext. In order to extract to sim file, type ext to sim. In order to open Itsm, type Itsm inv2.sim. Type watch Vin and Vout. Type D. You can see both the values are X and X. Then type, give low value to Vin. Type S in order to see the output. You can see the output is 1. If I give high value to Vin, type S, then I should get the value as 0. This is 0. In order to see in the analyzer, type A and A, Vin and Vout. Go to zoom, then full. So you can see here, when input is 0, output is 1. When input is 1, output is 0. So this is the waveform of CMOS inverter, and this is the layout of a CMOS inverter. Now let's see the layout of a CMOS inverter that is drawn from an untwisted schematic. So open the terminal window by pressing Ctrl Alt and T. Type magic. Now we will draw the schematic corresponding the layout of a untwisted schematic of a inverter. Now type grid. First we will see by using the commands. Type grid. Press Z to zoom in. Now when I refer to untwisted, then the PMOS can be drawn as this. Type paint anvil. Then now the P select, the P diffusion layer. Type paint pdiff. Of the same length, we need the N diffusion layer. So type paint and diff. So now the PMOS and NMOS are drawn. Now I have to connect the terminals. So first draw the gate. Okay, type paint poly. Paint poly. Now the gates are also drawn. Now we have to connect from here to here. Paint poly. Now the gates are shorted. So this is the input. The source is connected to VDD. So we'll connect the source to VDD. Type paint M1. Now this source is also connected to VDD. This source is connected to ground. The source of the NMOS is connected to ground. Now type paint M1. So this is connected to VDD. Paint VDD. Paint M1. Paint M1. Now this is VDD and ground. Now we have to connect the two drains. Drain of the PMOS is connected to the drain of the NMOS. So select the area. Select the area and type paint M1. Okay. Now since we have mentioned, we have placed all the layers. Now let us place the contact. So since this is a 3 width, we'll place a 3 by 3 contact. Paint and this is a P diffusion layer. So paint P diffusion contact. Similarly, place a P diffusion contact over here. Type paint PDC. Now after placing the P diffusion contact, we have to place the N diffusion contact. So select the area and type paint N diffusion contact. Now select the area, paint and diffusion contact. Now after the N diffusion contact, we have to place the substrate contacts. So this is the N substrate contact. So type paint NWC and substrate contact. So similarly over here, type paint NWC. Now after placing the N substrate contact, We have to place the P substrate contact, paint, PWC, paint, PWC. Now let's omit this extra part. Erase. Okay, now this is the VDD. So left click, right click, then right click on this corner, then label VDD. So this is VDD. Now label ground, left click, right. Label ground. Let's zoom out. So this is the input and this is the output. Now type paint poly. Now we have to extend this also. Paint M1. Now these are the inputs and outputs. So left click, right click, and label in, and this is the output. Label out. So this is the untwisted form of schematic. This is drawn from the untwisted form. You can see this is the PMOS, this is the NMOS. These two are shorted, the gate are shorted, drain shorted. Source of the PMOS connected to VDD, source of the NMOS connected to ground. Now save INV3. Save INV3. Have to find the DRC errors. DRC find. There are no DRC errors. So we will extract all. Then extract to spice. The spice file is generated. Now exit. If I want to see the spice file, then vi inv3.spice. So again the P diffusion, the P MOSFET and N MOSFET are of same area. This is MOSFET, M stands for MOSFET. VDD in, out, in, ground. This is ground and FET. This is the area of diffusion 40, perimeter of diffusion 26, area of substrate 40, perimeter of substrate 26. Similarly, it's same for the cases of both the PMOS and NMOS since the W by L ratio is same. And in order to exit, press colon and WQ. If I want to see my layout, type magic inv3.mag. Okay, now this is the layout. Layout of a CMOS inverter. Now let's see the layout of a CMOS inverter from the Untwisted Schematic by using the toolbar. Now open the terminal window by pressing Ctrl Alt T, then type magic, press enter. Now this is the layout window and this is the TKCon window. In order to grid in, press G in your keyboard, then press Z in order to zoom in, shift Z to zoom out. Go to options, toolbar, so you can see the P well, N well, P diffusion, N diffusion, metal, and here the PD contact, the ND contact, the N substrate contact and the P substrate contacts. Now, in order to draw the layout from the untwisted schematic, the PMOS should be drawn like this instead of this. So, we have to draw the PMOS first, then the NMOS. So, in order to draw the PMOS, select the area, then middle click on the anvil. Then left click, right click, then middle click on the P diffusion layer. Okay, so now this is the PMOS. So this selected area, I will draw the NMOS. Then middle click on the N diffusion layer. Next we have to draw the poly. So this is PMOS, NMOS. Now we have to mention the terminals. For the gate terminal, we use poly. So from here, then middle click on polysilicon. Okay, this should be in the center portion. So similarly, over here, middle click on the polysilicon layer. Now we have to connect from here to here. This is the gate. This is the gate of the NMOS. So middle click on polysilicon. Now we have to draw the source. The source is connected to VDD. So middle click on the metal layer. So this is my source and this is the source. The source is connected to VDD. Okay, now middle click on the metal layer. So this is the VDD. Now select this and type erase. Okay, now similarly the source of the PMOS, the source of the NMOS is connected to ground. So select the area and middle click on the metal. So this is the source. Now the source is connected to ground. Okay. Okay, you can see this is the untwisted form. Now zoom in. This is VDD. Okay. Now this source is connected, source of both the MOS, then the gate of both the MOS are connected. Now the drains. The drain of the NMOS is connected with the drain of the PMOS. So select the area and middle click on the metal. Now after these connections we have to place the contacts. So zoom in. Since this is 4, we have to place a 4 by 4. Select the area and then middle click on the PD contact, that is the P diffusion contact. This is the P diffusion contact. After that we have to place the N diffusion contact. Sorry, this is the P diffusion contact. Since this is the P diffusion layer, PMOS, we have to place the P diffusion contact. After that the N diffusion contact. This is the ND contact. So now middle click on the ND contact. Similarly over here. After placing the diffusion contacts, have to place the substrate contacts. Left click, then right click. So this is the N substrate contact since the N well is present over here. So this is the N substrate contact. This is also the N substrate contact. This is the P substrate contact. So middle click on the P substrate contact. Now before going for labeling, this is polysilicon, so middle click on polysilicon. Middle click on metal. Now this is the input, gate terminal is the input and the drain terminal is the output. This is not a compulsory rule, but over here the input is taken from the gate. So before that, zoom in, we have to label the VDD. Now label VDD and label ground. Label ground. After labeling the sources, the next is labeling the inputs and outputs. Label in, this is label out. Okay, now save it. So save INV4. Now DRC find. Let's see whether there are any DRC errors. There are no DRC errors. Type extract all, then extract to spice. Now exit, type vi inv4.spice. So this is the WIL ratio is same. This is VDD in out. VDD is the source, out is the drain, in is the gate. Similarly, here the source, this is the drain, and this is the gate. This is the area of diffusion. You can see the area of diffusion and the perimeter of diffusion, and all of the parameters are same for both the PMOS and NMOS. So in order to exit, press colon WQ. If you want to see the layout, type magic inv4.mag. So this is the layout. Zoom in. So this is the layout of a CMOS inverter. Now after drawing the layout from the untwisted schematic, let us simulate the ext file in the sim file in Itsm. So open the terminal window, type magic inv4.mag. This was the layout file. Now you can see this. Let's zoom in. There is small modification needed in the input, that is V in instead of in, and V out instead of out, and VDD instead of VDD exclamation, and ground instead of G end exclamation. So after taking the changes, extract first, go stepwise, then extract to sim. Then you must be thinking, how do we do these changes? Then just select the area, middle click outside, then again middle click on the metal layer, either from here directly or from the toolbar. Then as usual you are used to label, just label it as GND. Similarly with the other three. Then save, then extract to sim. Then type Itsm inv4.sim. Then type watch vin and vout. Type D for display. Now give low input to vin and see the step output, that is 1. Give high value to vin, see the step out, that is the output is 0. If you want to see it in an analyzer, type ANA vin and vout. So when input is 0, output is 1. When input is 1, output is 0. Actually you cannot take the input as A and B or in and out. You need to mention it as V in and V out. Similar is the case with VDD. It's not VDD exclamation, it's VDD. And this is GND. This is the layout of a inverter that is drawn from the Untwisted schematic.